Hello. Thank you for joining us. My name is Jeff Bowles. I am the Risk, Safety, and Industry Relations Manager for Pigeon Mountain Industries and the host of this PMI Technical Webinar Series. Before we begin, I want to address some housekeeping items. All attendees will be muted during the entire webinar. The presenter may ask a poll question that you can answer quickly on the right side panel controls so that we can get the results during the presentation. We will have time at the end of the presentation to answer any questions you may have. For questions related to the presentation topic, you may type in and send questions at any time during the webinar. You may use the chat function, which is separate from questions function, for any other comments you have. The webinar will last a total of 30 minutes. We may go over the time period depending on how many questions we have. If you are having trouble with your sound, you may switch from computer to the phone or vice versa as needed. Okay, let's get started. Today's webinar is presented by Aaron Dover and is titled Artificial High Directionals in Mountain Rescue. Aaron Dover has been with Pigeon Mountain Industries for 4 years and currently works in commercial account development. He is a level 1 rope access technician and a volunteer with the Alpine Rescue Team based in Evergreen, Colorado. Without further delay, I present to you Aaron Dover.
Thanks a lot, Jeff, and thanks to everybody who is taking time out of their day to join us here at PMI and just talk real quick about some portable high directionals in the mountain rescue environment. As Jeff alluded to, I work in commercial business development for PMI and do quite a bit of work as a liaison with our training division, Vertical Rescue Solutions. So connecting folks with gear and helping to provide some of that training. As Jeff mentioned, we're going to be talking today about high directionals in the mountain rescue environment. And you'll likely be seeing some additional webinars in the future on the same exact topic. There's quite a lot to cover when it comes to this topic. And so we're going to be doing a little bit now and a little bit more down the line. So keep your eyes open for additional webinars along this topic line. So without further ado, the problem we're going to be talking about today is friction. So friction is the problem that the high directional solves in the mountain rescue environment. And friction, as you all may or may not well know, is can either work for us or against us. And it's considered to be a frenemy of ours. So it can be our friend or our enemy. You can see the skier on the right, he's happy he's going downhill, on snow, whereas the guy on the right has a little bit harder time going down on the grass. So it can either work for us or against us, and the trick is to use it to our advantage when we can. So, as I mentioned, friction is going to be a discussion that we could have. It could be a discussion all on its own. However, today we're going to just focus on how it applies in the mountain rescue environment when we're dealing with an edge, whether we're either going down over an edge or trying to come up over an edge. We need to discuss how that comes into play. So we're not going to go macro view on friction. We're just going to focus here on how it applies with an edge. So one of the variables that we can't control in our mountain rescue environment is where our rescue takes place, right? So when we are called to the scene, we typically respond and there is an edge and we're not in control of kind of where that edge is and how it's going to affect our rescue. And so the angle of that edge, if we have a patient that's over the edge, and that angle of the edge above affects how much friction we're going to have, whether we're raising or lowering down over it. So, and you'll have to pardon my crude illustrations here, talking about the straight vertical the triangle down there is a 90-degree, and then something with a little bit shallower of an angle to the right is going to have less friction. So more friction. So the triangle diagram on the left, obviously it's going to be helpful for us as we're lowering a load over that. There's going to be more friction on an edge like that, whereas on the right hand side, we're not going to encounter as much friction just due to the shallow angle of that edge. So for example, we're just going to kind of go down the line here. Looking at in a lowering situation, we know that any friction over the edge can reduce forces on our anchors. So when we're lowering a rescue load, it works very much in our favor and can reduce the friction up to 2.5 times. So making a 600-pound rescue load feel more like 250 pounds on our anchor. However, if we were to go ahead and flip over and make this a raising situation, that friction is going to work against us, right? So that 600-pound rescue load is going to feel more like 1,500 pounds on the anchor, just due to that additional friction that we encounter when we're going to raise up and over that edge. So definitely a key thing to think about as we start to get into the high directional conversation. Just how we want to use friction and what we're thinking about when we're working with an edge. So obviously this has been a problem that's been around for quite a while. It's something that a lot of teams have encountered and continue to encounter. So we want to take a look here at what has been done in the past to manage the friction and the load over an edge to kind of mitigate those problems that we have. So as we'll see here, one of the ways that we do this is with a tree or a natural feature in the environment that we're able to use. So something like putting a pulley or a high directional up in a tree is a great way to manage the friction problems that we're going to have on the edge. So in this photograph here in front of PMI Denver, you can see that we have a pulley strapped to a RAP 3 pulled to on a tree. And this is great because we're able to elevate our rope up and over a hypothetical edge down below. So one of the lines here would be going to our rescue load, the other would be going down to our anchor. Trees are great because they're natural. They're quite abundant. So when we have them and we're able to use them, it's a really good thing. And however, the drawback with using trees and other natural features as a high directional is that we're not always in control of where we place the tree. And sometimes we get lucky and the tree is right where we need it to be. Other times it's not where we need it to be and it won't help us much. So so that's one way that friction's been managed in the past. Another way it's been done has been with a timber high directional. This is something where you'll see, certain logs kind of lashed together with rope, and this is kind of creating a impromptu tripod, if you will. However, that takes a certain level of know-how to put that together, and trust in the materials that you're using to do it. Plus, I imagine it to be quite time-consuming, so it's an option. Another way that's been developed to help manage a patient come up and over an edge is the pike and pivot method, which I'm sure quite a few folks here on the webinar are very familiar with. We're going to take a look at it here. Essentially, this was done in our Denver office in our training facility. Here's a patient being raised up and over the edge. And so the pike and pivot, essentially what we're going to do is raise him in a vertical configuration, and he is going to be able to then get brought up and over the edge by either teams on the top or another system. So it's just another way to manage the load to essentially stand it up on edge and then move it up and over the edge to kind of help ease that transition. Another way we can kind of look at starting to get something up and over an edge is by vectoring. And you don't see this very often, but vectoring can be quite challenging. In this situation here, what we're looking at is a mine shaft that you can see is approximately 15 feet by 10 feet. And down below the mine shaft, you can see the teams working on the haul lines. And where that left blue arrow is pointing, you can see the rope kind of going over the edge and then down the hole. So there's a situation here where it would have been nice to have a high directional or some way to get that rope off of the edge of the mine shaft. So what we're looking at doing when we're vectoring is actually pulling that load line off the wall to kind of help ease that transition and make it easier to negotiate. So always a challenge, but it has been done in the past when needed. So, and our final way that we can look at getting open over the edge is just pure brute strength. Having somebody go up and actually pull the line and help make that transition for the rescuer and the subject easier to come up and over the edge. So what the heck is a portable high directional? After we've gone over all of that stuff, what are we exactly talking about then? The short answer is that a portable high directional is a tool used to manage friction over the edge. So it's carried into the field by rescue teams. They bring it in, they set it up. And as you can kind of see here in this photo, this high directional goes together quite easily. All it's doing is he's going to be lowered off the edge there, and we are raising those two white ropes up off the rock, so he's able to do that. So by changing the path of the rope up and over the edge, we're managing the friction problem. So high directionals can help you in two different ways. They can serve as a redirect of the rope lines. So essentially in this photo here, what you're looking at, you have one set of ropes going back to the anchor, the other set actually going down and over the edge down to the rescue load or to the load in general. So that is just essentially holding the ropes up and over the edge so that the friction on the edge does not come into play, whether you're raising or lowering. The other way in which you'll see a high directional, particularly a tripod or a bipod, is a means by which to provide a high point over an opening of a confined space. So in this application, the tripod or the high directional is actually the anchor. And when you have something like this, where you're using the high directional as an anchor, you will notice that the tripod is not tied back at all. In this kind of application, the subject there is actually our resultant force. So when you're using high point over an opening, the subject or the load is going to be your resultant. So high directionals typically seen in the following configurations. As we'll talk about a little bit, the monopod there on the far left, that is going to be your probably your fastest setup and certainly the lightest setup going into the field for particularly for a backcountry rescue situation. They're essentially very good for tight spaces as well. You can see it does not have much of a footprint, where the bipod does have a larger footprint. However, the bipod, in my opinion, is probably the easiest to set up, particularly if you're going to be going in if you're turning this thing sideways as opposed to facing forward. Probably the most popular high directional you see out there is something, the tripod. So that comes into play in many different areas, realms, particularly in the fire service market, confined space rescue. You'll see it a lot in access as well, folks using something like that to facilitate a rescue in a confined space or a mine or something like that. The quad pod on the far right, definitely with the fourth leg, gives you a lot of additional strength and a much bigger footprint. However, you don't see much use in the US. You tend to see quite a lot of it in the international realm. So, and as I mentioned, you'll tend to see these things in confined space rescue, mine space rescue, the fire service, industrial access, urban search and rescue, and also mountain search and rescue, particularly when we're begin to interface or go on interagency calls where we're working tightly with folks in other services that may be using these more than mountain rescuers. Some of the traditional barriers this is a very good way to help you protect your systems and your loads and manage friction. And so, what has been a traditional barrier in the past as to why we haven't brought, these heavy duty pieces of gear into the field. And the reason being is it can be resource intensive. Maybe there's a perception that it's rigging intensive. Perhaps bringing a tripod into the field is doesn't make sense because it's way too heavy. When we're hiking in 8 miles, is it time consuming, resource consuming? And I've seen a lot of videos on YouTube of these things toppling over, and is it safe? So the question out there is, what can we do to make this safer? And so is it safe? But looking at some of the reasons why some of these high directionals are tipping over, and we get into looking at why that's happening, and it appears in a lot of cases it's just not because the product itself failed, but because perhaps we didn't have a complete understanding of the way it was rigged and the way our load is going to be coming up and over the edge. So managing our vectors and our forces comes into play when we try to make sure that these stay upright during the rescue. And as you'll see, as mountain rescue contends and the technologies and the products continue to evolve, we're seeing that there's a lot of lightweight, fast, stronger gear being moved into the rescue environment. As you can see here, we've got cord rated at 19 kilonewtons. You've got 11 mil rope now, getting close to 40 kilonewtons. We have the ability to use plug and play anchors. So that same type of theory applies to our high directionals. No longer are we have to lug in as much gear as we had to in the past. If we wanted to implement a high directional into our rescue, there is the ability out there now to use lighter weight materials to give us that same capability. As you'll see here in this slide, we have two different high directionals for mountain rescue being used. On the left, we have the SMC Vector. This is a brand new product just developed by SMC. Extremely lightweight, 3.5 pound monopod, and anybody carrying it into the field notices right away how light that thing is. It's extremely easy to rig and goes together very nicely. On the right-hand side of the page here, we've got our standard pterodactyl gin pole. Essentially, this is going to be a little bit taller. You can make that gin pole upwards of 12 feet and has a lot higher capability and capacity to give you in your rescue load. This thing is a little bit more bulky, but if you don't need something with that much capacity, the Vector is also an excellent option as it still helps you raise those ropes up and over the edge. So here a little bit more about the Vector, some stats, some dimensions on it. And what I'm going to end up doing actually at the end of the presentation is I can send out some paperwork on both the Vector and also the gin pole to help kind of give you an idea of what it can and can't do. So as you can see here, this is a 2-inch wide pole. Rigging plate on the bottom is 4.5 inches wide and weighs about 3 pounds. As a high anchor, you've got a working load limit of 1 kilonewton, and as a high directional, your working load limit is going to be a 2 kilonewton capacity. And there's an exploded view of it. So you have the ball foot, you also have a spike foot on the very bottom, you have rope horns on the top and bottom, and 2 rigging plates. So lots of different ways to rig the this thing, and it does work very, very nicely in the backcountry. Some concepts we'll take a look at. Resultant is a key term and something that we're going to be looking at while we begin to set up our monopod, whether we're using the pterodactyl or the gin pole. Essentially, the way we want these high directionals rigged is we want that resultant, which is the force, velocity, or other vector that is equivalent to the combined effect or 2 or more vectors acting at the same point. And essentially what the term is referring to is if you're looking at this this picture here, the pulley on the carabiner, you've got the yellow rope going up and over the pulley and then down the other side. So your resultant force is the bisection of those 2 lines. That is where the force of the that is where most of the force is going to be directed. So when we're looking at setting up the vector or any other gin pole, we want to rig it so that our forces are going right down the spine, right down the gin pole itself. As you can see here in this photograph on the right, we have the blue line going up and over the pulley and then down, and our vector or our resultant force is actually the monopod itself, and that's exactly how we want that thing to look when we're rigging it. We want the forces driving down that gin pole. So that's an excellent illustration there of a resultant. And one thing to bear in mind while we're getting these high directionals set up in the field is how is my resultant going to change throughout the course of my operation with the high directional. As you can well imagine, this setup will work well for 99% of the rescue itself. But when we get our patient or our subject to the edge there and we begin to move around, stand up, move off to the side, what have you, the resultant is going to change, right? So it could go, the resultant could go backwards to looker's left here on this photo. And once we do that and we knock the high directional out of, knock the resultant out of that footprint there, then we're going to get in trouble. So one thing to keep in mind is pay very close attention to your resultant forces throughout the course of the rigging and setup of your high directional. And I will say that the resultant, you always want to keep it in the footprint of your high directional, whether it's a gin pole like this, a monopod, a bipod, or a tripod. You want to keep those forces inside the footprint. It's just very well illustrated here in a monopod where you have the ability to see that resultant goes right down the monopod. And there's another look at it. 2 different ways. As a result, as a high directional in that type of configuration, where it's changing the path of the rope up and over the edge, as I mentioned, you want that resultant going right down the pole. As a high anchor configuration, as we have on the right, your load is going to be your resultant. So a couple things to look at while we're getting ready to set up our monopod. And before we put any kind of load on it, make sure our tiebacks are in place. They're secured and they're tensioned properly. We want our feet set and secured, and we want to shake prior to loading the thing. So on the gin pole, the vector there, it's a very, the rigging plates on the side allow you to do your tiebacks and ensure that you're getting good angles on those. You want them to be, if you have 4, you want to go 90 degrees between each of them. If you have 3, then you want 120 degrees between each. So just in the plate there that you're rigging with helps to self-center those. So also prior to loading, you want to shake it, make sure that that thing is bomber. It's not going to be moving while you begin to load it. And also, as I mentioned, you want the resultant verified with your loaded pulley to ensure that your resultants are in the right place and where you want them. So some advantages and considerations we're going to be looking at, what is my load? What am I trying to accomplish? Do I need a bigger monopod, or do I need something, or can I use something smaller? So comes into play when you're beginning to consider what equipment you're going to be using to facilitate your rescue and your edge negotiation. Another thing you're going to want to consider is my monopod high enough to accomplish getting my rescue up and over the edge, right? So if you're looking at the photo on the right, you can see how we begin to approach the height of the monopod there. When we look at our litter, then we take into account our spider, and then perhaps a pulley hanging down. So we want to consider our clearance as well when we're coming up and over the edge. Is that something that we're going to be able to clear an edge with? And those are things that can be easily mitigated by adjusting the size of your spider. Perhaps rigging a pulley, using a sling instead of a carabiner up at the top there. Just simple ways that you can begin to save a little bit of space and be able to use that monopod. So as I mentioned earlier, we do have a lot of capability now to bring in some lightweight, stronger, very extremely versatile gear into the mountain rescue environment. And I think there's going to be more to come. And as I mentioned earlier in the presentation, we're looking at making this a little bit of a series. So the next presentation, we're going to be talking a little bit more about some of the more technical capabilities and questions you might have with a high directional in a mountain rescue environment. And with that is all I had for the day. Are there any questions?
All right, Aaron, thank you for that educational presentation. We will now answer any questions that our attendees have. So please type in questions in the section on the control panel to the right. We will attempt to get to as many as possible. So do that now if you have any questions. And I believe this video is showing Aaron setting up a tripod there. You can see how easy it is. One person can do it. Cool. Okay. So here's question number one. The question is, can I use the SMC vector as a horizontal beam anchor over a hole or trench?
No, definitely not. The vector isn't rated to be loaded mid-shaft like that, so you can't use that as a horizontal beam. The pterodactyr, so the orange and gray option, you would be able to do it in that capacity, just because the walls on the tubes are much thicker and they're rated for much more weight than the vector. So if you're going to do that, I would recommend using the pterodactyr in a horizontal beam configuration.
Okay. Going to question number two. Which is better, the pterodactyr or the vortex?
Well, it depends. Like I said on the last question, it depends on what you're going to be doing with it. Both of them are really good. Just depends on what your application is going to be. The vortex, I'm partial. I mean, I would say the pterodactyl is certainly more capable and more flexible, I guess, has a few more options as far as how you configure it compared to the Vortex. But again, I work with it every day, and I don't work with the Vortex every day. So I would say the pterodactyl just because of the amount of things you can do with it.
The right tool for the job, it sounds like, right?
Yes.
And Aaron has put a poll up for all of our attendees. If you could answer that, please select just a yes or no simply. The question is, do you currently employ a high directional on your team? And that'll give us kind of an idea of the level of knowledge on this topic, just on people attending the webinar, and we can get the results of that poll quickly if you answer now, and we'll go on to our next question. And that next question is, when I'm using a tripod as an anchor, how do I figure out the resultant force?
Okay, so this is what we touched on earlier, where we were looking at the confined space, and I'll see if I can find the slide here. But essentially, when we're using the tripod as an anchor, our load is going to be our resultant. So whatever is going down the hole, that is going to be the forces that we're putting on the anchor, on the tripod. So in this photo here, where we have a guy in sked going down a manhole, it looks like he is going to be the resultant when we use the tripod as an anchor.
Okay. Okay. Again, anyone answer that polling question while we're still live here? That would be great. Just simple yes or no. Click yes or no, and we'll go on to the next question. Have you seen the video of the Fort Wayne, Indiana AHD failure? And if you have, can you describe where you see the failure in the process?
I do believe I know what video they're talking about. Essentially, it's what for anyone not familiar, if you just do a Google search of it, you'll see essentially what they were performing was a high line, and what it appeared was kind of like what we were just talking about, where the vector went outside of the footprint, and I think that's what happened. I'm not an expert or privy to all the details, but in my kind of what I saw, I think that may be what happened.
Okay. All right. The poll is open. Aaron, there. Do you want to close out the poll there and see?
Shh. 80% of attendees
The
are currently.
attendees, yeah.
Yeah.
73% say they use a high directional, and 27% say no. Let's close that out. And we apologize if you couldn't see any of the reference pictures during the poll, so we'll close that out now. Let's see here. All right, here's the next question. How does the weight of the vector compare with the weight of a single leg of the pterodactyl or monopod, Jim Pole?
The weight of the vector is about 3 pounds, all pieces put together. So it's definitely a lot lighter than leg of the pterodactyl. So certainly one leg of the pterodactyl, I don't have an exact measurement for you, but I know that the entire system is roughly 88 pounds. So I would say you're looking at about a 7 to 10 pound savings between the the vector and the gym pole kit.
Okay. And the same with the height. You said the vector is about 3 feet?
Yeah, the vector is 3 feet. The pterodactyl the gym pole can go up to 12. So
12 feet.
a lot more. You can get a lot more height.
And which would be more beneficial over a right angle edge?
Well, as I mentioned, I would say it depends on what you're trying to accomplish. I mean, if you can get away with a 6-foot monopod or a 3-foot monopod, or if you need 12, certainly you need 12. But a lot of times, the additional height isn't necessarily needed. If you can get away with a lot more, just depends on what kind of environment or situation you're in, and what you're bringing up or down over the edge.
Okay. So, okay, let's see. Moving on to the next question. Can a standard pterodactyl kit be used to configure a monopod, bipod, tripod, quadpod? Is that or are there are all the parts included, or are there additional parts that you need?
Yeah, so if you have the entire pterodactyl tripod system, you're able to break it out and use it as a tripod, bipod, or monopod straight out of the box. So you have that flexibility. You can make a monopod and a bipod, connect a highline to each other. So you can do a lot with it.
Okay. So you need it is it for a quad pod? You need an adaptive
Yeah,
additional
that would
headpiece.
be that would be additional, correct?
Okay.
Yep.
Okay. Oh, let's see here. Any other questions anyone has? We had one attendee uh, make more of a comment and say the resultant, they were saying the resultant is the sum of the load and the anchor forces.
Anchor forces.
Yeah. And
Um,
not just the load. And I don't know if that refers to uh, they said the resultant is the sum of the load and the anchor's forces, and not just the load. So I guess I guess it depends on whether you're talking about an anchor configuration or a high directional redirect kind of situation.
yeah, I mean, I wish I had his email or phone number. But it sounds like, if you have a rope going back to the anchor, you have forces on the anchor, and then you also have the load on the other end, and the resultant is, I think what he's saying is the combination of the both ends of the rope, but they're directed down that resultant angle.
Hmm. Okay, great. Hopefully that kind of clarifies.
I could be way off base. I would certainly welcome talking with the person, for
Well, it's
sure.
kind of these are complicated discussions, abstract discussions a little bit, you know what I mean? Like, and also like you said, every situation that, in mountain rescue is different. So you never know what kind of edge you're going to get, and what tool is the best thing right away. I think that's why having um, a, a very adaptable piece of equipment that can, like the pterodactyl seems like that you can use a monopod, bipod, tripod, quadpod. I mean, that gives you quite a few options in terms of
Sure.
tackling your,
Yeah,
whatever challenge you may have.
absolutely. And, obviously you got to consider, am I hiking this thing 500 yards up the hill, or am I going 8 miles in? I wouldn't want to carry the pterodactyl 8 miles, but I wouldn't be
Hmm.
opposed to carrying the vector 8 miles.
Right, exactly. Let's see. And if anybody has any more questions, it sounds like we've had a couple of comments. I think any questions that anybody has at this point? like I said, this is definitely a very technical discussion, and so I think some of our, we're going to get more technical as our webinar series progresses and things like that. And you definitely covered the bases there. Aaron, is there anything you would like to add before we sign off?
Not at all. My contact information is there. If I didn't get to your question or comment, or you want to chat further, please feel free to give me a call or an email, and be happy to continue the discussion. But just wanted to say thank you to everybody who joined us today, and thanks for coming out, and look forward to seeing you on the next one. And stay safe out there.
All right. Well, to learn more about artificial high directional training, please contact Vertical Rescue Solutions, the information can be found at pmirope.com. We would like to thank everyone for attending today's PMI Technical Webinar Series. This webinar has been recorded and will be available soon at pmirope.com. Again, we are looking to put together webinars each month for the rest of this year, one at least each month for the rest of this year. So please, if you're not on our mailing list, get on our mailing list, or go to Facebook and you can find us there, Pigeon Mountain Industries, and we will continue these discussions. As always, if you have questions regarding gear, equipment for work at height, or any training, please contact PMI, either our technical department or customer service, and we will be happy to help you. So thank you very much for attending, and as Aaron said, be safe out there, my friends. Take care. We will now end the podcast, the webinar. Thank you.